man, where's Ante? We gotta start this dynamics project.
What up, James? Oh, you want to start that right now? Alright, I'm on my way.
James Ripple and Ante Pehar presents ME 101 AP11 Rigid Bodies Demonstration with a Motorcycle.
Wow, that was crazy!
What are the dynamics behind this? First, we can refer to example 17.6 in the class textbook for a similar situation. For this problem, we will be solving for the minimum coefficient of static friction between the back wheel and road surface in order for Ante to do a wheelie. Example, lift the front tire off the ground. Let's analyze the dimensions of this problem. This figure illustrates the two center masses, Ante and the bike, and their dimensions. Now let's construct a free body diagram to determine the forces.
This figure illustrates the force due from the rider, the dirt bike, the frictional force, and the two normal forces from the tire. We assume that NA would equal 0 because the rider will be doing a wheelie.
Now let's construct a kinetic diagram. This figure illustrates that both the rider and the bike have the same acceleration.
The equations of motion yields that the sum of the forces in the x is equal to the mass times acceleration in the x directions. Therefore, 79.38 plus 106.14 times acceleration is equal to FB.
Also, NB minus 778.71 minus 1041.24 is equal to 0, since NA is equal to 0. Also, the moments at B is equal to the kinetic moments at B, thus illustrated in the equations below.
Solving for the unknowns yields NB is equal to 1,819.95 newtons, FB is equal to 1,395.11 newtons, and AG is equal to 7.52 meters per second squared.
Finally, the minimum coefficient of static friction for the back tire and the ground is equal to the frictional force of B over the normal force of B, which yields 0.767. Now, understanding the dynamics behind this stunt, let's take a look at the video again in slow motion.